Hello, welcome to my math class. This is Mr. Joseph Yamusa. The last time we met, we began with an algebra, that is the foundation of algebraic expression. Today, I want to look at a subtopic and the algebra, that is multiplication and divisions of algebraic expression from basic 7 to basic 9. So I encourage all basic 7 to 9 students to share this link with their colleagues and they will see an impact in them in mathematics whilst we go on with this channel. In our previous lesson, I gave some exercise to be tried and the solution we provided in our subsequent lesson. So now look at the solution in our previous lesson that was given to my learners. Now the first trial work was minus 2 into bracket 7x minus 2 bracket close. Then minus 4 into bracket 3x minus 8 bracket close. And the answer is minus 26x plus 32. The next trial work was 2b minus into bracket 5 plus 2b bracket close minus 7. And the answer is 10b minus 12. The next trial work was 4 into bracket 2t plus 1 bracket close. Then minus 3 into bracket t minus 2 bracket close. And the answer is 5t plus 10. Followed by 2 into bracket 6x minus 5 bracket close. Then plus 3 into bracket 2x minus 1. Then bracket close. And the answer is 18x minus. The answer is 18x minus 13. Now, our next topic is going to be on multiplications and divisions of algebra. Under multiplications and divisions of algebra, we are to apply the principles and rules of indices that will aid us in solving the multiplications and divisions of algebra. Under multiplications and divisions of algebra, the first rule we are to use here is the rule of indices or index. The rule states that when numbers or alphabets are having the same base, we add their exponents. So we have exponent 2 and exponent 2 and they have the same base. So I'll pick one of the base, that is a, then pick the exponent or powers, that is 2 plus 2. Then 2 plus 2 give me 4. So I have a to the power 4. Followed by x exponent 2 times x exponent 4. Now, the x and x have the same base, so I can add their exponent or powers. So I have x exponent 2 plus 4. So I have x exponent 6. The next one is going to be y to the power 4 times y to the power 3. Now the y and y have the same base, so I can add their exponents. So I have y to the power 4 plus y to the power 3. That gives me y to the power 7. Now let's look at law 2 under the index or index law. Under law 2, when numbers or variables are dividing with the same base, here you subtract the exponent. Here the base is x and they are dividing. So I'll subtract the exponent. So exponent 4 minus exponent 3. So 4 minus 2 will give me x to the power 2. The next one is going to be y to the power 5 and y to the power 2. They have the same number of base, so I'll subtract the exponents. So y to the power 5 minus 2, that will give me y to the power 3. Followed by base 6 divided by base 2. Base 6, base b divided by base b, they have the same base. So here I'll subtract the exponent, that's exponent 6 and exponent 2. So I'll pick one of the base, that's base 2. Base 2, then I'll subtract the exponent, that's 6 minus 2. So my answer becomes b to the power 4. Followed by a to the power 7 and a to the power 5. The a and a have the same base, so I'll subtract the exponent. So I have exponent 7 minus exponent 5. So 7 minus 5 will give me a to the power 2. Now let's look at law 3 and the index. That will be used to solve under algebraic expression. Now, the rule states that when a power is raised to a power, we multiply the powers or exponents. So here the exponent or powers are 2 and 2. So I multiply 2 times 2. So 2 times 2 give me 4. So I have x to the power 4. Followed by the next example. Here, if a power is raised to a power, we multiply the powers or exponents. So here the exponent or powers are 2 and 3. So I multiply 2 times 3. And 2 times 2 give me 6. So I have y to the power 6. The next rule also states that when a power or a base is raised to a power, we multiply the powers or exponents. So I have 3 times 4. 3 times 4 give me 12. So I have a to the power 12. The next one also states that when a power is multiplied to a power, we multiply the powers or exponents. So 4 times 4 give me 16. So I have b to the power 16. Now, with the rules of indices, we can apply the rules of indices to solve this algebraic fraction, and also with the application of the highest common factor to solve this algebraic expression. Now, I have 18 and 6. 18 and 6, I'll look for factors. And note, the factors is the highest common factor that can divide 18 and 6. The highest common factor that can divide 18 and 6 is 6. 6 will divide itself 1 and divide 18 3 times. So I have 3 over 1. Then the x to the power 3 and x to the power 1. I will have to subtract their exponents since they have the same base. So I have exponent 3 and exponent 1. So x to the power 3 minus 1. That will give me x to the power 2. So my final answer becomes 3x to the power 2 or exponent 2. The next example, to have 20a to the power 4 or exponent 4 divided by 15a to the power 2 or exponent 2. I'll look for the highest common factor that can divide 20 and 15 and apply the rules of index to solve a to the power 4 and a to the power 2. So 20 and 15, what number can divide 20 and 15? That is 5. 5 divide 15 3 times and divide 20 4 times. So I have 4 over 3. Now 4 over 3, no digit can divide 4 and 3 at the same time. So 4 and 3, I can reduce 4 and 3 to the lowest term. But with a to the power 4 and a to the power 2, I have to apply the rules of index. And the rules state that when numbers are dividing with the same base, I will subtract the exponents by picking one of the base. So base a and I have 4 to the 4 minus 2. So base a and 4 minus 2 will give me 4a to the power 2 divided by 3. The next one is going to be solve examples that have negative attached to it. So let's look at the first example. I have minus 12b q. I have minus 12p to the power 3 and q to the power 1 and over 4p to the power 2 and q to the power 2. Now, with 12 and 4, I have to apply the principles and rules of division. So I'll look for a number that can divide 12 and 4. A number that can divide 12 and 4 is 4 itself. 4 divide itself 1 and divide 12 3. And note, the 12 has a negative sign aside attached to it, so to affect the negative 3. Then apply the rules of index to solve the p to the power 3 and q to the power 1 and also p to the power 2 and q to the power 2. Now with the p to the power 3, p to the power 3 and p to the power 2 have the same base, so I'll subtract the exponents. So I have 3 minus 2. Then q also have q to the power 1 and q to the power 2. So I'll subtract the index or base. Index or exponent. So when I subtract the exponents of 3 minus 2, I have 3p to the power 1. Then also, if I subtract the exponent of 1 minus 2, I have negative 1. Now, the negative will affect the 3. Then you have minus 3p to the power 1 and q to the power negative 1. So my final answer becomes minus 3p, then q to the power negative 1. Now, the next example also has negatives attached to it. So apply the rules of mathematics to solve the negatives, and the rules of division to solve the 15 and 25, and the rules of index to solve the u to the power 5, u to the power 4, and v to the power 3, and v to the power 2. Now, and the rules of division, negative will cancel negative. So the 15 and 25 will turn to positive. Then I apply the divisional rule. What number can divide 15 and 25 exactly without any remainder? So I'll look for a digit that can divide 15 and 25. So that digit will be 5. 5 divide 25 5 times and divide 15 3 times. Then u to the power 5 and u to the power 4. I'll apply the rules of index. So 5 minus 4. Then also v to the power 3 and v to the power 2. I'll apply the rules of index. So v exponent 3 minus 2. So the 5 minus 4. So I have 3 u to the power 1. That is 5 minus 4 give me 1. Then also 3 minus 2. That will give me 1. So v to the power 1. So 3 v to the power 1 and v to the power 1, the answer becomes 3uv over 5. The next one also states that when a power is raised to a power, we multiply the powers. Or when a cube is raised to a cube, we multiply the cube. So here, I have 3 exponent 3 times r exponent 3. Then followed by the denominator, that is 5 to the power 2. 5 to the power 2, the 2 will multiply the 3, because when a power is raised to a power, or when a cube is raised to a cube, multiply the cube or powers. So I have 3 to the power 3 times r to the power 3, then I have 5 to the power 6. The 5 to the power 6, I'll multiply the exponents, that is 2 and 3. 2 times 3 will give me 6. So 5 to the power 6 and also 3 to the power 3, I have to multiply them using normal numbers. So 3 to the power 3 means that 3 times 3 times 3 times 3. That will give me 27. And I have r to the power 3. Then 5 to the power 6, I'll multiply 5 times 5 times 5 times 5 times 5. That gave me 15,625. That is 15,625 as my final answer. Now, let us move on to algebraic expression involving fractional terms. And the algebraic expression involving fractional terms, we apply the rules of fraction to solve this algebraic expression. And the rules of fraction state that when a fraction has division attached to it, we apply reciprocal rule. So the fraction, that is 12x squared 5y cubed, has division attached to it, that is 18x squared and 35y to the power 1. So when I apply the rules of fraction, the rules of fraction state that when a number has division attached to it, I apply reciprocal. So the 35 is called denominator and the 18 is called numerator. The 35 will move up. So 35y will move up and 18x squared will move down. And the division will turn to multiplication. Then I'll now apply the rules of index and divisional rule. So from the arrow there, you can see that the division has turned to multiplication. And the 35 has gone up and the 18 has gone down. And we now have multiplication attached to the two fractions. So since we have multiplication attached to the two fractions, I can now apply my divisional rule. When you pick 18 and 12, a digit can divide both 18 and 12. So the highest number that can divide 18 and 12 is 6. 6 will divide 12 2 times and divide 18 3 times. Then I have 5 and 35. What number can divide 35 and y? And 5y to the power 2 itself. That is 5. 5 divide itself 1 and divide 35 7 times. Now, so we now have 2x squared times 7y over y squared times 3x squared. Then, I will now group like terms. So 2 multiply 7 and x squared will multiply y. Then 3 will multiply y. Then I will now apply the rules of index. Now, I have 2 to the power 2
over 2 to the power 2. 2 to the power 2 over 2 to the power 2, that is x. So we'll have x to the power 2 and x to the power 2. I'll subtract their exponents since they have the same base. So 2 times 7 will give me 14. So 14 x exponent 2 minus 2. Then y exponent y minus 1 minus 2 divided by 3. Then I have 14 times x to the power 0. That is 2 minus 2 give me 0. Then y exponent negative 1. That's 1 minus 2 give me negative 1. All divided by 3. Any number raised to the power 0 is 1. Or any variable or digit raised to the power 0 is 1. So x to the power 0 give me 1. So 14 times 1. Then y to the power negative 1 divided by 3. So 14 times 1 will give me 14. Then 3 times 1 give me 3y as my final answer. Now, learners, I will allow you to try the following examples that will be solved in our subsequent lesson. That is trial work 1 to 4. So thanks for watching.